Welcome to Frost Sullivan's Growth Podcast. This series brings together key insights from our research, growth analyses, and thought leadership, highlighting the strategic imperatives shaping industries, technologies, and markets worldwide. In this episode, we focus on the strategic imperatives shaping the critical power industry, distilling essential perspectives to help teams understand what is changing, why it matters, and how organizations can align strategy with emerging growth priorities. Critical power has always been about ensuring uptime. So what has changed, and why are conventional approaches no longer sufficient?
The operating environment has changed significantly. AI workloads, high-performance computing, and higher rack densities are increasing power demand, while grid capacity is becoming more constrained. At the same time, organizations are facing faster load fluctuations and tighter expectations around reliability. Traditional strategies focused on adding capacity, planning for peak loads, and maintaining individual components. Today, those approaches don't fully address the complexity of modern power environments. Organizations need to think about the entire power architecture, how electrical infrastructure, cooling systems, controls, and protection technologies work together to support reliable growth. The priority is no longer just keeping systems online, but building infrastructure that can scale without increasing operational risk or stranded capital.
That broader systems perspective sets the stage for our next question. If infrastructure is becoming more interconnected, how should organizations strengthen resilience across the entire power ecosystem? Many organizations are investing in on-site generation, battery storage, and advanced controls. Is that enough to improve resilience?
Adding these assets is only part of the solution. The bigger challenge is making them operate as a coordinated system. Facilities increasingly rely on a combination of utility power, generators, battery energy storage systems, power protection equipment, and digital controls. When these assets operate independently, organizations can face synchronization issues, delayed transfer events, and limited visibility into overall system performance. Integrated resilience requires real-time visibility across the electrical chain, predictive diagnostics that move beyond scheduled maintenance, and closer coordination between power systems, software, controls, and service teams. The objective is to reduce operational blind spots while improving response during disturbances.
As these systems become more connected and digitally managed, another challenge naturally comes into focus: security. Power infrastructure is becoming increasingly digital. How does that change the security conversation?
Digital connectivity brings significant operational benefits, including remote monitoring, software-defined controls, and better system visibility. But it also expands the attack surface. Critical power assets such as UPS systems, switchgear, and energy management platforms are now connected across multiple locations, including distributed and unmanned sites. Security is no longer limited to physical protection or compliance requirements. Organizations need cyber-physical security strategies that protect connected assets and physical infrastructure together. They also need secure product design, ongoing vulnerability management, and stronger collaboration between product, software, cybersecurity, and service teams. Building security into system design helps reduce operational disruptions and protects long-term reliability.
Security is one piece of the puzzle. Another is ensuring that power can move reliably between multiple energy sources as electrical architectures become more dynamic. As facilities integrate utility power, storage, renewable energy, and on-site generation, what changes are needed in switching and protection?
Power systems today are much more dynamic than they were in the past. Electricity can flow through multiple sources, changing fault behavior, transfer requirements, and protection settings. Conventional automatic transfer switches and fixed protection configurations were designed for simpler architectures. They may struggle to support the faster switching, accurate coordination, and fault isolation needed in modern environments. Organizations should prioritize faster synchronization between power sources, digital switching and protection technologies that adapt to changing operating conditions, and stronger coordination from system design through commissioning. These improvements help reduce transfer delays, nuisance tripping, and operational disruptions.
That brings us to our final question. As infrastructure evolves, Organizations are also rethinking how backup power assets are used. Backup generators and battery systems were traditionally reserved for emergencies. Why is that changing?
Power availability is tightening, energy costs are increasing, and grid conditions are becoming less predictable. As a result, organizations are looking for ways to use backup assets for peak shaving, load shifting, and selective grid participation, rather than leaving them idle. However, greater utilization introduces new operational challenges. More frequent use can accelerate equipment wear, complicate fuel management and battery reserve planning, and reduce available backup capacity if not managed carefully. Organizations need real-time coordination between utility supply, storage, and generation, while ensuring backup capacity remains available during outages. They also need disciplined operating practices that allow participation in energy programs without compromising contractual uptime commitments or customer confidence.
So the opportunity isn't simply to increase asset utilization, but to do so while preserving resilience and operational readiness. The critical power industry is entering a new phase where infrastructure decisions are becoming increasingly interconnected. Higher power densities, constrained grid capacity, and more dynamic electrical architectures are changing how organizations plan, operate, and expand critical facilities. Success will depend on integrated power strategies that improve visibility, strengthen resilience, modernize power infrastructure, embed security, and maximize the value of existing assets while maintaining reliable operations. That's all for this episode of Frost & Sullivan's Growth Podcast. For deeper analysis, research insights, and strategic frameworks shaping future growth, explore our studies and resources at frost.com or reach out to our team at hello@frost.com. We'll be back soon with more perspectives to help you stay clear-headed and growth-ready.